What's up everyone, Patrick here, welcome back. Moving on to the next example. So what we have to do here is we have to sub in each of these values here. So notice that we're given certain values. So for example, here we have 3/2 for the variable r, and we have to sub that into the given formula and then evaluate it. All right, so starting with part A, we got pi r squared, so that's the formula, and then we have to sub in r equals 3/2. So it's just going to be some work, some more practice with dealing with first bed mass. Notice there's going to be different operations here, and then also with exponents. Notice that all of these formulas contain exponential expressions. So with part A, we got pi, which is just a number, and then we have r squared. So we're going to sub in the 3/2 for the r. So this would basically be pi 3/2 squared, like that. Then from here, there's multiple ways to go about it. So notice that we first have to deal with the exponent before we deal with the multiplication. So one way we can deal with it is we could just expand this. 2 is not too bad of an exponent, so we could just write 3/2 times 3/2, like that. And so if you do this, 3 times 3 is 9, 2 times 2 is 4, and then you would have the pi, like that. So that's one format you may see this in, that's given as an exact value where there are no decimals, but you may also see this and this multiplied and the final answer be in decimal format. And I think if you do this, you'd get around 7.07 if you round to 2 decimal places. Another way to do this is if you didn't want to expand here, as I've mentioned in previous videos, if you have a fraction to an exponent, well, what you could do is take the numerator to that exponent and the denominator to that exponent. And so you'd end up with pi times 3 to the power 2 is 9, and then 2 to the power 2 is 4. And usually you'll see pi on the right side of a number. That's usually the proper format. Right, so multiple ways to go about it. Either way, these are the two solutions. Right, moving on to part B, we got pi r squared h. Okay, so here we're going to sub in two values. So we're going to sub in 1.25 for r and then 4 for h. So what we would end up with here is pi, and then we'll have 1.25. That's going to be in brackets. That's going to be squared. And then we're going to be multiplying by 4 at the end, right? Pi r squared h, like that. Same thing, bed mass, we got to deal with this exponent first. So what is 1.25 to the power 2? If you input that into your calculator, you'd end up with 1.5625. And then we're going to be multiplying by 4. And then you can multiply all of these. So this times this would give you 4 times the 1.5625 would give you 6.25. And then we're going to be multiplying by pi. And then if you want to multiply those to get a decimal, if you round to 1 decimal place, you'd get approximately 19.6. Right, so that's the answer for part B. Moving on to part C, we have a to the power 3 minus b to the power 3. And we're told that a is 4, b is 3. So over here we'd have 4 to the power 3 minus 3 to the power 3. Be careful with your brackets. Make sure you put brackets here. Here it's not as critical because this is positive and this is positive, but if those were negative, then it is critical, as we've seen in previous videos, of putting that negative base in brackets. So from here we got to evaluate the exponents first. So 4 to the power 3, that would give us 64, right? 4 times 4 times 4 is 64, minus 3 to the power 3 would give us 27. And then 64 minus 27 would give us what? 37? And so that would end up being the answer to part C. And then in part D, we have x squared plus 2 times x, where x is 3. So this here would be, again, put this in brackets. So we'd have 3 squared plus 2 times 3. Okay, so if you start getting expressions like this, I'd recommend just putting brackets like that, right? Again, it's positive here, so not as critical, but you're going to see over here when we plug in the -2, it's going to be more important then, right? So working with this, we could work with this exponent. So we would have, let's split these up here. We would have what? 3 to the power 2 is 9 plus, let's just leave that as is. And then we do the multiplication before the addition. So that would be 9 plus 6, 15 ends up being the final answer for part D. And then finally, we got part E. So let's actually continue it over here. So we're plugging in -2 for all the x values. So notice there's already a negative here. So let's put those brackets I was talking about. So we have a negative, and then we have a -2 to the power of 2. Right? Be careful here. There's 2 negatives. And then we have +3 times -2 plus 4, like that. Okay, now because these terms are separate, you could work, like for example, you could do the exponent here and then you can multiply over here, right? You can't multiply this -1 and this -2 because they're sort of attached. You have to do this first, but if they're separated like this, you could work with both at the same time. But just to keep things simple, I'll just do one thing at a time. So it's going to take a little bit longer, but nevertheless, the steps will be more clear. So over here, what do we work with first? The exponent, right? So -2 to the power 2. -2 times -2 is +4, but we still have that negative in front. That's like a -1, if you want to put that in brackets. So we'd have -1 times 4 plus 3 times -2 plus 4, like that. Right, and then we can do the multiplication. So let's multiply these two first. -1 times 4 gives us -4 plus 3 times -2 plus 4. And then we can multiply these two. So we'd end up with -4. 3 times -2 gives us -6. And then we have plus 4, like that. And then from here, -4 minus 6 gives us -10. -10 plus 4 would give us -6. Or another way to look at it is the -4 and the +4. Those just net out to 0, and you're left with a -6. All right, so when you're subbing these values in for certain variables in certain formulas, just be careful with the BEDMAS.